Hello and welcome back. Today I have a little PLL board, and it is also from the design is from the BG7TBL, famous by now. I would think I have a lot of stuff here, and this is the board. And the idea is that you just put in on this SMA, you put 10 megahertz in, preferably from your lab reference, and then you can program each output. It has 6 outputs, somewhere between I think 200k and 200 megahertz. And so that would be nice if you need a lab reference other than 10. Like I did for my Marconi, I had this special FTIS5 that also outputs 1 megahertz, but with this board I totally control it myself, because I know my spectrum analyzer runs on 50 megahertz. You have some other boards that run on 25. I don't have it here, I think, but maybe you need something weird like 4 point, I don't know, something like from an old frequency counter. Then this could be great to use. And also it has also a 10 megahertz out, so you don't necessarily lose a connection. And yeah, well, if you run out of connections on your distribution amplifier, you just all program them to 10 megahertz and then it should be good. But it comes in a nice little box like this with the anti-static, but that's it. So I'm already trying for 2 weeks to get the software from the seller, and in the end, because I bought this in AliExpress, but I found another seller on eBay, and yeah, the seller from eBay sent me first without I even didn't order it with him, so I ordered something else there. But thank you, guy from eBay, and let's see what it is. Let's have a closer look. Okay, and here we have the board. You're looking now at my PC screen. As you can see, you put here the DC power in right here. I'll look at something else to point it out. You can put the DC power in here, and you put your 10 megahertz in here, and then here you have your output 1 up to 6 and your 10 megahertz out. And here you can connect a serial connection. So this one should be able to go to your serial connection of your computer. Pity it's not USB, but it is what it is. Here we have power and lock light. So if the power is on, it will blink. Once the PLL is locked, it will be statically on. And when the external reference is connected, the light will also be on. This is what the bottom looks like. As you can see, the PLL here, there is some buffering going on to all the connections, and as you can see, the 10 megahertz, here is the 10 megahertz in, goes also through the buffer. One goes to here and one goes to your output. Here there is probably, it's the regulator, because the plug-in is here. And we need to see how much power this thing needs. And this is the software I was talking about. And as you can see, this is totally untranslated, but I have seen screenshots that this area here you can select English, open COM port, close COM port. You can set your frequencies. And I think if you write it to EEPROM, then it's probably the default setting after it is lost its power. So it took me some time to get this program. As you can see, it was also a little bit difficult to look for this. And also the board doesn't really have a name. So, and this is the board. So let's start with the power. I did find some information. Sorry, I will. So it is the 10 megahertz 6 channel board. This is a sort of a type name, so maybe that is it. The 10M-6 PLL. As you can see, the input signal needs to be between 0.5 and 3.3 volts peak. So well, that is the value that comes out of my distribution amplifier. That's not a problem. And you can do a signal between 10 and 200 megahertz. That is the output in steps of 10 hertz. So that's quite precise. And it is then a square wave output. Oh, here I see something weird. The output 3 is output 1 divided by 1, 2, 3 or 4, or a full number. So okay, so the output 3 is a special output, and it is just only divided, so that is not exactly but that's okay, because I can do, for instance, if I could put 10 in my output 1, and then I can just divide by 10, and then I have a 1 megahertz out. So that's the same for output 6. So output 3 and output 6 are always a division of the output 1 or output 4. Okay, it's a bit weird, but okay. The frequency change can be done by the others. 232, the voltage should be 4.9 to 12. So maybe there is a step up, step down converter. So I like to go as close as possible to its real voltage, so it doesn't get too hot. Explanation of the LEDs and how to connect the RX to the 3, the TX to the 2, and the bound rate. And this is if you like to send it yourself. Okay, if you don't have the software. Okay, let's start. I did have a look at the power regulator right there, and it is AMS 1117, and it seems to be a 3.3 volts regulator. So I'm really planning not to put in more than 5 volts, because why would you put in 12 and then it needs to dissipate a lot of heat. So let's put 5 volts and let's see what we can do. So I have more or less 5 volts on the Farnell. It doesn't matter too much, because it needs to be, well, at least above 4, I would think. I found a DC connector I also ordered before. Just gonna put it in there, and we should at least have the power light switched on if we do this. And probably the PLL will not lock, so it will only blink, I would say. So maybe I can do from this side. It does. You saw it came up and then it stopped. Okay, that I didn't like. Why? Okay. My clip wasn't connected well, and now it is. And as you can see, it did start up, and it is blinking. So that means it is switched on, and it is not locked. PLL cannot lock because there is no input signal. So let's put external signal from my lab reference. I need a BNC with SMA. I have somewhere here in the back. So I bought all these very nice little cables with one end SMA, the other BNC. So that's very easy to handle. And so I'm feeding in 10 megahertz. So then the yes, external already, without I'm even connecting it. Why doesn't it fit? Yes, it does. I'm too soft. Okay, as you can see, the PLL is locked and the external input is on, so that's a good thing. Now I'm just wondering what we have in all the outputs, so I'm just going to check what it is by default. I think you can read the HP, so that is good. I have another BNC right here. Low input. Let's see what we can first do. The external 10. A few more digits. Well, as you can see, that is exactly 10. It stopped. The connection is really not good. Okay. But as you can see, that is exactly 10. So the circuit works because this one also running on external reference. So let's see what is on the first output. I've connected now to the first input, and it seems that the first output is 1 megahertz. So let's go to the second. Two megahertz. The third one is 5. Then the fourth is 1 again, 2 and 5, and the last one is 10. That is that is the programming that is in my STIS5. It is funny. Okay, let's see if we can connect the serial connector. I do not have a proper serial cable, but I have this console cable for, I think it was from an HP switch, but I can just well, measure which is pin 3 and just solder it to the board. So I will just cut this cable. Okay, well, I beep out. We need pin 2, 3 and 5, and I beeped out which one is which, so I know now the RX is green. Well, makes sense. TX is red. Oh, it's nice. And pin 5, that should be ground, that is the yellow one. So we can fix those to the board, put this one in the computer. I actually have a computer that still has a serial port, and then we try to install the software. Okay, we are installing the software. I have here in the folder, I unzipped it. As you can see, they supplied the OCX file that is for communication with the serial port. Apparently it doesn't come standard with Windows. And indeed, when we start, it says that it doesn't understand the dependency. So we need to install that. I already googled that, and I have a little install file here. What we need to do, so we need to copy the file into the, this is 64 bits, so we need to copy the file here, and then we need to run some commands that you can just copy paste. I will try to get that in the screen. You can open a DOS box by typing in cmd, and then it will pop up, and then you don't click it, but you right click it, and then you say run as administrator. And then we put it here, and then we just gonna copy paste what is there. So select the first, copy, right click here, it will appear, bloom, succeeded. Then we copy this, do again, boom, module not found. I'll just ignore, copy this thing, and it says it's good. So now it's all registered. Let's see what happens if we start the thing. Okay, we have something. I'll put it on a black background so we can see better. Okay, a lot of question marks. This was the language, I think. Okay, English. Okay, the board is switched on. Maybe I need to open first. Open. It is opened. Okay, and then it read the frequency. Okay, so it does work. Cool. So it says 1, 2, 3, 5. Okay, now let's put in 10. 12, 15, 10, 15. Right. Writing complete. So the communication seems to work. So if I say close, close, and I say open, it reads and it has everything. Okay, let's see if that is really what happened. This is cool. Okay, let's see if the frequency is really what we thought it was. I also put it on the scope, and the oscilloscope says that the first is exactly 10 megahertz. It is sort of a square wave, but it is not connected properly. So okay, well, it is a square and it is 10, so that is good. The frequency counter says the same. Let's switch over to the second port. That should be 12, and it is. The third port was 15, and it is. So then I don't understand what I said about the first and the between the first port and the third and the fourth and the sixth, because it's just doing exactly what you program. So 10, 12, 15. Okay. Now I like to see if we can also do like 19 megahertz or something, just to see what happens. Okay. We go back to the computer. I don't think you can see. Okay, but I will program. So I will put 10, 10, and 10, and 10 and 25 megahertz. Now I will do 3 times 10. I will do 25, 50, and they say it can do 200, so I will do 200. And I say maybe I need to do run program. Yes, writing complete. Okay, now let's see. 10, 10, 10, 25, and it is exactly 25. We have 50, and it is exactly 50. And then we should do 200, but I cannot measure on this board 200, so I switch to the B channel, and then I should have 200. Come. Well, it should go up to 200. I couldn't do it on the last port, but it makes sense because they said no, the port 6 is a division of the port 4, and the port 3 was a division of the port 1. So what I did, I just put the frequency of the fourth. I put now just on the highest, so then the last port can be a division of that, so it just lower. So I did now port 4 is 210 megahertz. It should only go to 200, but apparently it goes a lot higher, so that's nice. And then I can measure on the other. I put 25. 25 on the 6th. And it is. So that worked. So you just need to be sure that if you have a higher frequency, you put it always on the 1st and on the 4th. Don't ask me why. It is like that. Yes, and now I can put it again. But I'm kind of, as I always try to push the limits of the frequency counter, I also want to push the limit of this device. And they say it goes up to 200. But I'm already at 210. So what if I just put it on 250? Writing frequency. Writing complete. No, or the level is too low. Then I'm trying to put it on my proper meter here. Go to the second channel. No, okay. The level is too low. Okay, back to 200. Writing frequency. Yes, 200. Okay. It works really good. 220. 220 still works. 230. No. So that's it. It's a little bit for the advanced user, but it's great for if you need a lab reference for 25 megahertz or any other value than 10, because your GPSDO or your Rubidium just gives you 10, which is great. You can build all your dividers with little logical ICs, and then to create less, but to create more, it's a little bit more difficult. And this one is great because it has 6 ports, and you can run it at low as 100k up to 220 megahertz even, we saw. So maybe if I want to make an external reference input to my spectrum analyzer, because it runs on 50, you have these little devices. I think they run on 25. So it's easy to program. It's a pity it's an old-fashioned serial and it's not USB, but I can maybe put a converter in between. Or I even saw converters from serial to LAN, and then I just put my serial devices all in my switch, and then I just communicate from anywhere immediately. So that is great. It's not necessarily cheap, but I think it's very useful, and I just wanted to show you. The software is a little bit tricky, but I will put it in one zip, so if you are interested in this device, you don't need to go through all this asking your sellers, finding an eBay seller where you don't even buy it, who is providing it for you. So I will including how you install it on your Windows with this extra module. I put it all together so you have it all in one piece. So that's it. Thank you for watching, and I hope to see you next time.